Thank you very much. So first of all, I'd like to thank the organizers and the volunteers and all this stuff for this incredible event. It's actually the second time that I take part in this event as a speaker, and not as a participant, and it's lovely to see all the people on the community. And it's also important to get rid of the code and the job at some point and spending some fun. So when I was discussing with my team what to bring to the table today, we assumed that there were going to be a lot of agentic, conversational AI, real-time AI stuff. And to be honest, it was a little bit boring to have just one more conversation about that. So we had a lot of use cases that were on a different path or a different direction. Certainly, we thought it was a really nice idea to introduce some of the use cases that we've been through that are not, like, let's say, real-time. They need a real-time response, but instead we have some batch solutions. So this talk is going to be divided in just 3 parts. We're going to spend a lot of time talking about one of the use cases, and then we're going to mention some of the other applications that we have carried out through these last months. Just to mention that some of the building blocks that are going to be discussed here are open source, or are to be open source. So I know that you guys love that. So in case you're interested, you can reach me out afterwards, and I'll give you the directions. So when I got the feedback from Luis, from one of the organizers, he told me, man, it looks like you're so much used to technical talks, and this doesn't have to be that much technical. So what I decided is to, instead of doing a technical introduction, giving a lot of information, all of the stuff, I just replace it. I throw everything away and put memes. So let's see if that works out, right? It's the first time that I do it, so let's see. Okay, this is not a meme, but this is close to. So let's talk a little bit about the bright side of GenAI. Obviously, the fact that GenAI is everywhere is not by chance, and it's because of their capacity with regards to emergent properties. Emergent properties is a hot topic that was carried out since the emergence of transformers back in 2017, so far ago, it seems. And ever since, we've been exploded in terms of how many things these language models can do, up to the point in which we can basically have a pay-as-you-go service that can carry out any single demo that we want, which is amazing, to be honest. This is also a very important and significant industrial revolution, the one that we're living in right now. So as you can see, there are a lot of papers, and these are just from last week. And these are all from reinforcement learning applied to language models, which is a hot topic ever since DeepSeek put it into the table again. And by the way, all of these 3 papers have something in common that you cannot see if you only go through the abstract. And it's something that I mentioned quite a lot in my talks, and almost no one notices it. And the thing is that there's the same single language model behind all of the experiments and behind all of these papers from the big labs. And it's not a model from OpenAI, it's not a model from Anthropic, it's not a model from DeepSeek, but instead it's a model from Qwen, right? Qwen is a big lab, and the Qwen 2.5 7 billion model is, in my opinion, and as you can see, as these folks' opinion, the best model out there, and it's fully open source, so you have no excuse to do your own stuff. Yeah, we're living in a time where, this is a meme, by the way. So we're living in a time where test time inference is going to be everywhere, and we're going to use so much more the models, because when you have, like 3 or 4 years ago, you had your BERT model for a name entity recognition solution. You only use it for that purpose. But now you can have your assistant as a psychologist, as a fitness coach, and as everything else. So we are into a point where compute is not a problem, as you can see from NVIDIA's stock value. But thank you. But data is the problem, right? Original, real, human data is the problem, and therefore we are in the era of synthetic data, and you can just scroll through LinkedIn and you'll find it out. And if you want to have a lot of synthetic data, you obviously need to talk about the price of that data. And obviously there's a huge amount of research regarding the inference efficiency. And here you can see the prices, the kind of the current prices from this analytics dashboard. That there is obviously an incredible competition on providing the lowest price and obviously at the most intelligence that is possible. So this is about the bright side, and there is not too much room for memes in the bright side, obviously, because memes are about bad things. So let's start with linked influencers, which is something that I coined like about over a year ago. Do you have the feeling that everyone on LinkedIn is smarter than you? Because I do. So, especially with this generative AI wave, you have the feeling that being a programmer is something that you can do by just pressing a tab and being a happy guy with a lot of hair in your head. But it's actually not. It's actually something like this. It's about something, being a fucking weirdo, in a dark room, very sad. Something happened on his hair. It's nothing to do with me, by the way. Generative AI, obviously, if you have the feeling that deep learning is getting easier, is because you're just paying too much attention to people on LinkedIn. It is obviously getting harder and harder and harder. And the reason why is because there's so many people working in there that it's impossible to get at the path that this flow is going. And I understand that a lot of the industry need a fast solution. And one of the points that these technologies aim to solve is they want to provide you with quick demos, quick proof of concepts. But if you want to move forward and scale that solution, you're going to find in a position where your third-party providers, your model providers, are not going to support you enough. This is the same meme as before because it is so much related with AI agents. So AI agents mean that we basically are exploding the inference time of the model. And again, this has to do a lot with the price that we are paying. So if you don't want to be burned out by your cloud provider, I mean, you can put cloud provider, you can put OpenAI here, it's fine. If you want to break the bank here, you just have to make sure that you start learning some MLOps, which is the topic of the next talk, by the way. So you make sure you're here by the coffee break. And certainly, there's a lot to do in these use cases with deploying your own stuff. So that's why we thought it was very interesting to bring it here. There's actually a quote. There's actually a quote by Tim Grover that I love to mention ever since I heard it. Not because of the quote itself, but because of the context in which it was said, which is, if you think the price of winning is too high, wait till you get the bill from regret. And the reason why is because that guy was trying to be an inspiration for his children, the same that many of us are trying to do. But I think this quote can have a twist related to this talk and say, if you think the price of deploying your own models is too high, wait till you get the bill from OpenAI. And that is my quote. So if you ever mention it, this is mine, OK? Thank you. Thank you. Thank you so much. This is like a monologue, right? It's kind of weird. OK, so let's get a bit serious. This is what I get paid for, I think. So this is a use case called call productivity management. So it's basically a use case in which we call the people because we are not getting paid, right? We are a bank. This is all about money, boys. So we have people makes call to customers, say, hey, your time is up, my time is now. I want to get my money back. So the traditional flow is, OK, there are agents making calls to customers. This is fine up to this point. What happens next is the supervisor gets some information about the call. And this was a bit of an horrendous process because there was like really poor quality transcriptions, some regex going on. Like, trust me, it was awful. And there is like less than 0.01 production data that is being crafted, gathered, and analyzed manually. So you can get an idea of how poor the vision and the analysis of the data that we were getting was before, especially taking into account that the salaries of these guys depend on that analysis, and depending on a human is something very hard. What is the new flow? The new flow starts by the same point, which is that we have replaced all men by women. No, that's not true. But it is that the agents keep making calls to customers as of now because it's really hard to get rid of this part. it's a very sensitive topic. You're talking about money, people. You really want to make sure that there's a human at the other side of the phone. But then we can get rid of humans and analyze 100% of the calls and analyze 100% of the transcriptions. So what does this mean? This means that we have over 100,000 calls per month to analyze, right? From on-premise services, get straight to the cloud, and we're going to discuss the details of the architecture later on. But have you ever tried to run 1 million prompts at once from a provider? No, not because you can't, so it's impossible. So you need to do your own stuff, and we're going to see how to do it. Then all of that information is gathered, go to the lakehouse, provided by a dashboard tool, and that way, agents are happier because now there's a fair comparison with others, and salary compensations are fair. So what kind of information do we get from those calls? Remember, we're asking people to pay, which is something that is not comfortable, and we basically get 3 types of information. One of them are protocols that agents have to fulfill through the conversation that are at the same time divided in 3 parts. One is the introduction, one is the negotiation that has some kind of, flexibility to go from one point to another, and then the closing of the call, which is basically, hey, my name is Antonio, are you whoever who has to pay their bills? Okay, I just call you to inform you, do you want to pay today? And then they give you an excuse, and then you close the call and write down what the customer said. So as you can imagine, this kind of problem could have been solved with a text classifier or a name entity recognition problem, but language models give you, I think the other one, no, okay, fine, thank you. So this could have been solved, and we did it in the past already with name entity recognition problems, for instance, and now language models give you more flexibility to tackle all the problems with the very same model. This part is also very sensitive because you need to have to get in touch a lot with stakeholders in order to get these right steps analyzed, because remember, salaries depend on this. And we're going to get into details later on, but what basically the process is performing an offline distillation of a model, and we get a model at the end of the day that does this task that is just less than 1 billion size, right? Billion parameters. The other information that we get is related to soft skills. We perform a really, really, really deep explorative analysis related to clustering and semi-supervised learning that we're going to see later on. And the things or the soft skills that we found, they were better for us to discriminate between promise to pay and not promise to pay, which is our main target, where effective communication, usefulness, active listening, clarity, and customer research. We extract scoring from 1 to 5 or 0 if it doesn't apply, because maybe they hear, hey, we are from the bank, and they hang up. That's awful. And we also provide sort of a clean summary with a language model of why that punctuation or that scoring was given to the agent. And the last bit of information that we get is completely unstructured. So we get basically text around summaries, positive points, improvement opportunities, customer objections, and advisor objections handling. And these 3 tasks are handled by a fine-tuning of the same model, which is what makes this problem much better and easier to maintain in production. So one of the key points here for this information to be handled effectively is to model the objections, right? So what kind of objections are the customers given to you? What kind of problems are they given to you in order not to pay? So again, we also performed the same analysis as in the previous step, and we found that there were 28 different reasons because customers don't want to pay, and some of them are surprising, but the majority of them are in this chart. There are some of them that are obvious, like I would be able to pay next week because of whatever, life is hard, and blah, blah, blah. And yeah, this is kind of the distribution that we are getting from customers, like partial payments, recurse promise, and reiterates the need to pay, and everything else. The language model, the process here is the language model generates a text, and then we have another model, which is a classifier. What I mean by a classifier is a sentence transformer. It's not a language model like OpenAI's one or Quen. And the only task of that model is to classify the output of the LLM and put it into one of these 28 boxes, right? So that way, we don't force the language model to put it into a situation in which it has to choose between one of 28 possible topics, but instead we give the language model the freedom to express what the problem was, and then we solve the task of classifying it more efficiently and better with another model. And that's going to give you also a criteria to detect data that is not working out in production. So having said all of this, the flow goes as follows. We get data from on-premise instances that is taken care of by an Azure Data Factory service in a special resource, which is the only one that is capable of moving data from on-premise to cloud. Then we have the first data landing resource group in Azure, which handles all of the data orchestration as well as the keys for encryption that we have. And then we have the space where we work on, which are the cognitive services, where we have deployed 3 batch endpoints, basically, which are services that we're going to get into detail right now. But basically, the process is divided into the speech to text, like converting the audios into text, discriminating whether a person said something or the other, and then the language model inference, right, which is the big deal here. So regarding the first one, I'm just making like a big zoom in on this case, because I find it's interesting to mention is this is done in Azure ML with Kubeflow pipelines. And one of the interesting things that we did here was, if you can see these parallel components, they are able to scale both horizontally and vertically. With the assistance of some of the Azure ML capabilities and Kubeflow. And the reason is that, imagine that you may have to process like 2 months of data at once. And that's like, again, the question that I mentioned before, like 1 million audios. And you have like maybe 3, 4, 5 different prompts for each audio. So that leads you to having 4 to 5 million queries to a model. So obviously you need to use a lot of machines and in order to finish in due time, and obviously to have a small model to make it run really, really fast. And for those of you who don't know what either horizontal or vertical scalability is, you can imagine your virtual machine to be Charmander. So horizontal scalability would be something like this, and vertical scalability would be something like this. Right? Just for you to know. Yeah, a lot of time without memes, guys. It is what it is. So this is the slide of trying to make open source great again. So this is the flow that we use for language model inference. So we have a small subset of audios from production that we craft and we analyze manually, obviously. And then we have a few candidate prompts that we use with a big language models, and that is the stack that we use, VLLM and Qwen language models. And what we try to do there is to optimize the prompts in such a way that we get the data that we want in all of those 3 steps before. When we calibrate, let's say, the prompts and the model, we go to an offline distillation pipeline through a lot of audios, like I thought it was around 45,000 audios. So we have a total of 130 training data for our small language model. Again, the model from which we distill is around 72 billion parameters, and the resulting one is less than 1 billion size, so over 60 times smaller. So as far as I remember, the throughput was over 40,000 tokens per second in an A100, so it's quite a lot. So again, going really fast through this, the production flow is we get the audio files, we get the metadata, we invoke the first batch API, we get all of the audios transcribed, and then we have registered as artifacts all of our prompts, our models, everything, and we have our custom engine to perform batch inference. We get our structured outputs, and by the way, this is a very hard task for a language model to accomplish, to generate structured outputs, and we get some post-processing layer regarding anonymizing the sensitive data, classifying the objections that we mentioned before, and so on. All of that happens in that blue box. And for the CI/CD, how do we do this? Okay, there are two criteria here. One is what I mentioned before. There are times in which your classifier of the objections is not going to be capable of having enough confidence to determining whether it is in one of the 28 boxes that you trained it for. So that is going to be, you set a threshold confidence in such a way that that is around 1 or 2% of your production data. And also, there are going to be times in which your language model, even if you have specifically trained for it, is not going to generate the structured output that you want, because these language models are exceptionally good interpolation machines, but sometimes they just mess it up. So that small batch of data from production is taken out, and then we again repeat the process basically from the upper side. We generate synthetic data, we make some kind of manual review, and then continue the training of the small model, and then we go back into production. So this is the kind of flow that we make, and it turns out to be quite convenient just for you to have an idea. Processing over 100,000 audios in production with all of this stack took less than $1,000, the entire thing, right? So it's something that is not kind of easy to achieve. And what are the additional applications? And I'm going to move forward real fast in case you have any further questions. So the first one, which is to be open source in the next weeks, is this one. I work extensively on this ever since I started working on conversational assistants before the GenAI explosion. And there is something in between having your training data and training your supervised model and just exploring, doing clustering, which is semi-supervised learning. And by leveraging algorithms like label propagation, you can have the best of both worlds, and having a lot of unlabeled data labeled, but in a good way, so to say. We have carried out a lot of optimizations in our code beyond the current implementations, which are sparsity, class balancing, using smart use of language models like sentence transformers. So if you're interested in this, make sure to reach us, because there are a lot of pretty cool things in this code. And also, there's an approach that we found pretty interesting with regards to document processing, which is a problem that we're tackling right now. The typical flow for analyzing PDFs is the one that we're seeing on the image, which is basically doing some OCR plus layout, and then having a language model to generate the embeddings of the chunks and blah, 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 and then you get the embeddings. So this process is too slow. If you have ever done it, this is very, very, very slow. And then, you have the text embedding model, you perform the comparison, and that's it. But there is a much more recent approach that you can follow, which is basically considering the PDF as an image, then using a vision encoder to generate the straight up the embeddings of each of the patches of the images, and then using a language model as an embedder and have your final embeddings. That process, as you can see there, is much faster, and it enables you to have almost real-time interactions. So if you are worried about an assistant of your company to make a fast embedding of a document that is being uploaded, this is a very good way, a very fast way, and very effective way of getting your data chunked. The only downside of this is that you need to take care of the deployment of the model, because they don't usually providers don't give you, the resources to deploy it, and you have to find your own. But we have also carried out a lot of work on that side. And then these pooling techniques, you can do a lot of optimization, because as you can see there are a lot of white patches, or a lot of patches of the PDF that are completely white, are blank without information. So you can basically carry out some pooling algorithms in that layer so that you can further optimize the information representation, because at the end of the day, what you want to do with this, using a multimodal language model, carry out the page in which the information is, and then letting the vision language model take care of the result. And in order to get the result of the query online, you can basically use the same language model and do the comparison. And those models, by the way, are the same one, right? The one from the left and the one from the right. So this way, it obviously has clear applications on real-time interactions because of how fast the preprocessing it is, but it is also a viable solution in terms of batch, because you can have any powerful machine that you want deployed in a cloud instance in batch, and there is no worry about the price because you can just raise it and turn it down as you wish, and then having the rest of the process online. So I think that's all from my side, actually. Hopefully you have enjoyed all of the memes. Maybe you have some questions for me. Thank you very much.